in this first part, we need to review the whole idea of slope. And slope comes up quite a bit in the ACT and in your future math classes. And a quick review of slope: if you have ordered pair x1, y1, and x2, y2, then your slope is going to be your changing in y's, so y2 minus y1 over x2 minus x1. You can also note that slope could be your function's value at one endpoint minus your function's value at the other endpoint over the difference of those endpoints. All of that is known as slope. Now, given a graph, I think y'all were told to also look at your slope to be your rise over your run. And so you can count how many paces up and how many paces over you go to get your slope. So in order to do that in the first few examples, notice here for our slope, we would have to count up. It looks like 3 paces. 1, 2, 3. So the numerator of my slope is 3, and then we would count over 1, 2, 3, and 4. So 4 would be our denominator, and so there would be our slope. Okay, moving on to our next one. Now this one, instead of rising up, we're going to have to move downward to get to our other point. So it looks like our slope, if we're moving downward, is going to be negative. So automatically I know I have negative, and if we count down, we have 1, 2, 3, 4, 5, 6, 7, 8. So I know I'm moving downward 8 and moving to the right 1, 2, 3, and 4. So my slope is negative 8 over 4 or negative 2. Both would be accepted. And finally with 3, well, 3 is a horizontal line, so this one's going to have a special slope. It's going to be a little bit different, and let's see why. Well, notice that we have been counting up or down, but we would not have any up or down to get to the next point, so it would be a 0 over. And our run, we would have to run over, looks like a total of 8. And so 0 over 8 is 0. So that's why horizontal lines have a slope of 0. Now, if we have our 2 points, this is where we're going to have to do our formula. So we would have our slope is, and we're going to have negative 7 minus 3 over negative 5 minus a negative 9. And so in the numerator we have negative 10, and in the denominator we have positive 4. So our slope, and we do need to reduce this, that would be negative 5 over 2. By the same process, again, for the next one, our slope would be negative 4 minus a negative 1 over negative 7 minus 2. And so in the numerator, we have negative 4 minus a negative 1. That's going to be plus a positive, so negative 3 over, and we're going to have negative 9. So notice a negative divided by a negative is positive, and we have positive 1/9. And lastly, number 6, again, same procedure. So we have 3 minus a negative 5. In the denominator, negative 1 minus a negative 13. And in the numerator, remember, we would end up with plus a positive. So we have 8 over, and here looks like we're going to have positive 12. So our slope this time, we can reduce top and bottom by 4. So it's going to be 2/3. So now we're going to compare this to our average rate of change, and hopefully we see it's the same exact thing. When we talk about the average rate of change of a function between 2 points, well, let's look. The 2 points is the slope of the line that passes through these points. That is your average rate of change. So this is called the type of line here, this line, that is known as your secant line. So that's good for us to know. We will be building on that. So again, that line that passes through those 2 points, that is known as your secant line. And if we want to know the slope of that secant line over this closed interval, notice it's the average rate of change, and we can abbreviate that instead of having to write it out every time. Let's call that AROC, average rate of change. And so it's really just talking about the slope of that secant line. However, we do need our function notation here. So we're going to have f at b minus f at a all over b minus a. That's going to be your average rate of change. Again, keep in mind it is just slope here, so don't let the wording mess you up. Okay, in our next section, we're going to find the average rate of change of the function over the given interval. So don't let the wording mess you up here. It sounds like it can be confusing, but don't do that. Don't let it bother you there. So this is going to be really your x1, and here's your x2, and the first thing I would do would be to find the ordered pairs. Let's do that first. So find your points. Oh, my pen quit writing, sorry. Find your points. So in other words, if we have the value x1, and that is an x value of -2, go over to your graph and find the y value that would go with that. And so it looks like the y value that would go with that would be a 1, wouldn't it? If we look over, we go back 2, and then we keep going till we get to the graph, it's going to be right here. So that's going to be -2, +1. And now let's find our other ordered pair. We have 1, comma, and if we go all the way to our graph, it looks like we're going to get to a -8. So now we're ready to find our average rate of change. So the second thing we're going to do is find your slope. That's all you have to do. Find m. So your average rate of change is really your slope formula. -8 minus 1, changing y's, over your changing x's. And so my average rate of change on this interval, well, the numerator is going to be -9. The denominator is going to be +3, so it's going to be -3. That's your average change, rate of change. Okay, so here again on number 8, first thing, let's find the points. So if we find those points, well then we've got, here we have 0 is our x, and if we look at our graph at 0, looks like we're over at maybe 7, and then at 4 it looks like we're at maybe 1. And so now for our average rate of change, our second thing is to find m. So the average rate of change here is going to be 1 minus 7 over 4 minus 0. So in the numerator I have -6, denominator +4. So let's see. Oh, no. This should have been -7. So then that's positive. I was looking at that. That slope would, or the average rate of change there would be strange. It shouldn't be a negative. It's going to be a positive. So, all right. So that's going to give me a +8. And so the rate of change there is 2. Number 9, now instead of trying to pull the values from a graph, we are going to be substituting in. And again, keep in mind, here are your x values. So if I want to find the average rate of change, then the setup of this is going to be f at 2 minus f at -1, and that's all over 2 minus a -1. And so this is where we're going to need our calculators, and we are going to be plugging all of this information into the calculators. None of this you need to do by hand. And hopefully when you sub into the calculators, f at 2, when you make that substitution, you should get -6 minus, and if you plug in -1, you're going to get -21, I believe. And that's going to be all over 2 plus 1, so 3. And when you put all that in your calculators, you should get 5. The same is true with 10. We need to show the setup, and I do want to see where you've set up these problems. So I need to see where you found f at -7 minus f of -9. And then all of that's going to be over -7 minus a -9. And hopefully when we type all that in our calculators, we should end up with a -4. So moving on to the next one. Number 11. Again, we need to see f at 7 minus f at 4 all over 7 minus 4. And f at 7 is going to be 183 minus f at 4 is going to be a -3, and that's all over +3. So hopefully we'll get 62 here. And then finally, number 12. Again, same setup. I do need to see this notation. F at 5 minus f at -2 all over 5 minus a -2. And f at 5 should be -567 minus f at 2 is a -21, so +21 all over 7, and we should get -78 there. Number 13, more of the same. Again, this process doesn't change. We're still looking at f at 8 minus f at 2 all over 8 minus 2. And f at 8 looks like, let's see, f at 8 is going to give us 4 over 8, so 1/2 minus, and on the other side we're going to get a -1, so that's going to become +1 over 6, and so that's going to give us 1/4. And finally, number 14, same process again, just different types of functions that we're subbing into. We have f at 7 minus f at -1 over 7 minus a -1. And now we go straight to our calculators. And this one, let's see, f at 7, we're going to have the square root of 12 minus the square root of 4 all over 8. And if we type all that in our calculators, it looks like we should get 1.464 over 8, and that is going to be approximately 0.18. All right, let's move on to some application problems now. All right, so for number 15, let's see, we have a company's total cost, so we have our cost function. And so find the average rate of change of the total cost for the first 200 units. So for the first 200 units, that's going to be from 0, isn't it? All the way up to 200. That's the first 200 units. So now we need to look at C at 200 minus C at 0, and all of that's over 200 minus 0. And hopefully when we type all this in our calculators, we get all of this worked out. We should end up with $50. And that's going to be per unit, right? All right, let's look at our next problem. We have a ball is thrown straight upward so that the height h at t in feet is given by our traditional physics equation here. Okay, so we do need to take note of that, and note that time is in seconds and your height is in feet. And we want to know the average rate of change in the height when the ball reaches its maximum height until when it reaches the ground. So we've got a couple of things we've got to do here. The first thing we need to do is to find, well, what is the max height? That's important for us to know, because if we don't know what the max height is, we can't find the average rate of change here. So let's see, we definitely need to go through and find that first. So we would need to put this equation in our calculators, and we could find the maximum value. So on this, that would be important. We need to graph, and then we need to find max value. So definitely need to do that. And if we do, we should get that max height to be about 2.5 feet maybe. And so we've got the max height until it reaches the ground. Well, if it reaches the ground, then the height would have to be 0. So I'm going to have to find that as well. So here, the next thing we have to do is find whenever the ball's on the ground. So that's going to be 0 equals negative 16t squared plus 80t. So here, let's go ahead and graph. Let's use that graphing calculator. Graph. And then the next thing we need to do is find zeros of our function. That's important. And so when the ball hits the ground, notice that when we do this, we should get 2 zeros because this is a parabola and a is negative. And so we have something that looks like this. And so notice this is the starting and this would be the end. And we should get our time there to be at 5. So now we have our time interval. Yay! So our time interval here for our average rate of change is going to be from 2.5 over to 5. That's what we're looking for. So the setup of this problem now is going to be where we find h at, h at 5, which we should know, minus h at, and let's see, what's going to be the other value? It was 2.5 maybe? All of that is over 5 minus 2.5. And when we type all that in our calculator and get all of those values, notice the average rate of change is going to be negative 40 feet per second. And I always get asked, can that rate be negative? Well, yeah, because the ball's falling to the ground. It's not staying up in space. So, yeah, it needs to be negative there.